So calculate the magnitude of the average force exerted by the brakes of a 2,500 kilogram truck to bring the vehicle to rest in 12 seconds if it were traveling at 30 meters a second before the brakes were applied. Okay, so our change in momentum, actually let's write this out properly. Change in anything is the final minus the initial. So our final momentum is what? 0. 0 minus our initial momentum is 2,500 times 30. Okay, so that's mass times velocity. 75,000. 75,000, now let's do Newton seconds because it's impulse. Oh, now that should be negative. Now what does that negative mean? Other direction, yeah. So if we're traveling in one direction, the impulse is acting in the opposite direction. Okay, the momentum is slowing us down. So we have our momentum, and then to work out our average force, we remember that force times time is equal to change in momentum. So again, our force is equal to change in momentum over change in time. So we have 75,000 over, how long? 12 seconds. 6,250.
Negative 75,000.
Look, we're not given a direction in the question. So yeah, you could do negative, just to tell you the direction. But in this case, if we're not given a direction, we can sort of get rid of that negative. Doesn't really matter. Okay, all we want is the magnitude, really. But yeah, the negative, even if you are given a direction, you can get rid of the negative and just be aware that it's acting in the opposite direction. Yeah.
It even says calculate the magnitude.
Sorry?
If it says calculate the magnitude, then you don't use signs.
Basically, yeah. All right, so there's our force, 6,250 newtons. So this should be a fairly straightforward calculation for you. A problem, an equation like this or a problem like this, you shouldn't have too much difficulty with. So you just need to work out the change in momentum, which is your impulse, and then remember that your impulse is equal to force times time. If you're given the time, you can work out the force.